As we sit on Earth, a small, fragile species on a speck of dust in the grand expanse of the cosmos, we often overestimate our understanding of the universe. We, as a civilization, tend to think that because we have the tools to observe the stars and planets through our telescopes, and because our sophisticated computers can crunch data from these observations, we know what lies beyond our world. With the help of our technological advances, we attempt to illuminate the dark corners of the universe, feeling confident that we can unravel its secrets. With every new discovery, we piece together narratives about the physical and chemical processes that govern the stars. We build grand models of star formation, cosmic evolution, and the birth of the universe, and we confidently call this science. We recount these tales as if they are fact, describing the genesis of celestial bodies, the forces that govern their movement, and the moment of the Big Bang, as though we have captured the complete picture of the universe's inception. Yet, for all of our advancements, for all our attempts to probe the heavens, there is still so much that remains beyond our grasp. Our knowledge is limited by the instruments we create, the observations we collect, and the theories we devise. As much as we can simulate the cosmos in our computers and develop elaborate theories about how things came to be, we are still small creatures, barely able to see beyond our immediate surroundings. We are limited by our perspective and by the fundamental bounds of human cognition. Occasionally, however, we dare to extend our reach beyond Earth and venture into the unknown. Probes like Voyager 1 and Voyager 2 represent humanity's audacious attempt to reach into the dark voids of space, places where no human has ever been and where no spacecraft has previously ventured. When these probes were launched in the late 1970s, it marked the beginning of an extraordinary journey that would take them beyond the farthest planets of our solar system and into the uncharted territories of interstellar space. The data that these probes send back to us hold the potential to rewrite the scientific narratives we have grown so comfortable with. Sometimes, the discoveries they make may suggest something completely new, perhaps even pointing toward a force of nature that we have yet to comprehend. And yet, when faced with the possibility of discovering something entirely novel, many scientists are often hesitant to fully explore the implications. They wave off such data, dismissing it as an anomaly, perhaps unwilling to challenge the foundational theories that underlie their understanding of the cosmos. The reluctance to consider that the universe might harbor forces or intelligences beyond our current understanding is a reminder of our inherent limitations as observers of the cosmos. Voyager 1 and Voyager 2 stand as shining examples of the power of human ingenuity. These two probes, launched by NASA more than 4 decades ago, are among the most successful and important scientific missions ever undertaken. Over the years, they have traveled farther from Earth than any other man-made objects, capturing breathtaking images of the planets, moons, and asteroids they encountered along the way. In addition to these stunning visual records, the probes have measured countless variables, radiation levels, magnetic fields, particle densities, that have given scientists an unprecedented understanding of the outer solar system. Voyager 1's journey, in particular, is noteworthy. On September 12, 2012, more than 30 years after its launch, it became the first human-made object to cross the boundary where the sun's influence wanes and the mysterious interstellar medium begins. This marked a historic moment in space exploration, as humanity, for the first time, touched the infinite darkness beyond the confines of our solar system. This area, this great void that makes up roughly 95% of the known universe, had never before been directly experienced by any spacecraft. The sheer emptiness of interstellar space is unlike anything we can easily comprehend. It is an almost complete vacuum, a place so vast and so devoid of matter that only a handful of particles float in each cubic centimeter. Who could have predicted that these humble spacecraft, launched from Earth so long ago, would be the first to explore such an alien environment? It's easy to imagine that Voyager's original designers, while aware of the probe's potential for longevity, could hardly have envisioned the momentous discovery their creations would eventually make. Voyager's crossing into interstellar space didn't just provide a scientific milestone, it also marked a profound moment in human history, one that reminded us of how much we have yet to learn about the cosmos that surrounds us. But what exactly is beyond the heliosphere, the region where the sun's solar wind dominates? Many people might assume that once a rocket leaves Earth's atmosphere and escapes the gravitational pull of our planet, it enters the same kind of space we see in images from telescopes like Hubble and the James Webb Space Telescope. We picture the deep, black void of the cosmos, peppered with distant stars, galaxies, and nebulae. However, the reality is much more complex. The space around Earth, the planets, and even as far as the Kuiper Belt, the region beyond Neptune that contains icy bodies like Pluto, is still influenced by solar radiation and magnetic forces. It's only when spacecraft like Voyager venture billions of kilometers from the Sun that they begin to encounter the true emptiness of space. The interstellar medium, this vast, dark expanse, is unlike the solar system we are familiar with. For years, scientists had speculated about what conditions might be like beyond the heliosphere, but they lacked the direct data needed to confirm their theories. Voyager provided them with that evidence, and the results were both surprising and enlightening. Researchers had long suspected that the density of particles would sharply decrease once a spacecraft crossed into interstellar space. In the solar system, there are approximately 100 particles per cubic centimeter, but scientists believed that number would drop to just a few in the interstellar medium. Yet, when Voyager's instruments began to take measurements near the boundary of the heliosphere, they recorded something unexpected, a sudden increase in magnetic force. This increase, which extended far beyond the region of the Sun's direct influence, suggested that the solar radiation forms a kind of thick buffer, a barrier that was stronger than scientists had anticipated. This discovery led researchers to conclude that the Sun's influence does not abruptly end at the edge of the heliosphere. Instead, it gradually tapers off, creating a zone where the solar wind collides with the interstellar medium. This boundary, sometimes called the termination shock, is a place of stagnation, where solar radiation meets the faint pressure of interstellar space. Beyond this point, the true interstellar medium begins, a region that had only existed in theory until Voyager crossed the threshold and provided real, tangible data. In 2015, Voyager's measurements became even more detailed, allowing scientists to get a better grasp of what interstellar space is like. The changes in particle density and magnetic field strength aligned with many of the predictions researchers had made, yet there were still some anomalies that challenged their understanding. For example, the magnetic field outside the heliosphere seemed to behave in ways that weren't entirely expected, raising questions about the nature of the forces that govern this region. Despite the success of Voyager's mission, recent developments have brought new mysteries to light. In the last few years, scientists have noticed that Voyager 1 seems to have become confused about its position in space. For a spacecraft that has functioned normally for decades, this was an unexpected development. At first, NASA downplayed the issue, explaining that such problems were inevitable as the spacecraft aged and moved farther from Earth. Suzanne Dodd, the project manager for Voyager 1 and its twin, Voyager 2, at NASA's Jet Propulsion Laboratory, explained that the issue likely lay with the spacecraft's Attitude Articulation and Control System, AACS, which controls the orientation of the antenna. According to Dodd, the AACS was still operational, and Voyager 1 continued to receive commands and send data back to Earth with the same signal strength as before. However, the telemetry data from the AACS was garbled and unassignable, as though the spacecraft no longer understood its position. What made this issue even stranger was that the antenna remained properly aligned the entire time, otherwise, no signal would have reached Earth at all. NASA's team worked to resolve the issue, but by that time, some scientists had begun to take notice of the oddness of the situation. Voyager 1 was still sending data back to Earth, but the data appeared to be meaningless. Yet, no alarms had been triggered, and the spacecraft had not switched into its safety mode. This raised the possibility that the data was, in fact, correct and that NASA simply didn't understand